Hello friends, today I will explain the concept of skewness of a set of numbers with a real data set. So this is a data set from one of my papers. It is on the Nifty 50 index. Nifty 50 is a stock market index in India. Now, what does that indicate is, let us not get bogged down with all that. But what we have here is the some numbers which are reported against years. So we have 23 years, 1995, 95, 96 to 2017-18. We have some numbers which represent the change in the Nifty value within 1 year for each of these years. Now, if I want to do a statistical analysis of these numbers, return values, and of these return values, then some basic operations, the summary statistics. You have learned mean, median, standard deviation, variance, all that you can compute. But I would focus today on something called the symmetry aspect of the data, and in this process I will also show you another software called R, which is very useful and handy to use. So I have this data here in my R software package. I have already done some operations here. I'm going to redo for you. So if you can see, I'll just write AR. AR is the set of numbers that is there in this table. AR, so the right column. So this column that is stored as AR in R. You could call it something else. I am since it is annual return, I have abbreviated it as AR. Now so this will display you the numbers in exact order the way they are in this table. So the first is minus 1.47. You can check. So here the same order. Now what I can do is to sort these numbers, that is arrange them from left smallest to largest. So the command is sort AR. So obviously now the arrangement to change. You have the smallest number minus 36 on the leftmost and the largest number on the right side. Now if I may compare these numbers, so what is happening? So from negative I am moving towards the positive values. How many negative values I have? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 negative values and rest are positive. So 23 minus 9, that is 15. 14 positive values. So there are more positive values over here. But that's not the only issue. Let us compare these values. You see that when I see on the left side, the negative numbers are minus 36, 25, 14. Now when I go to the right side, the three largest numbers 64, 71 and 77, they are much away from the zero than this. And if you see these three numbers 36, 26 and 18, they almost balance these. They are almost the positive counterparts of these three numbers. So for minus 36 I have a plus 36, for minus 25 I have a plus 26, and for minus 14 I have a plus 18, and for minus 9 I have a 17. So you see it up. If I exclude these three numbers, then the negatives and the positives are almost mirroring each other on the extremes. But these three numbers make a huge difference in the sense that these are very large positive numbers for which there are no negative counterparts. Now, if I compute a mean of these numbers, what do you expect in such a case? Obviously, if these numbers were not there, these three positive numbers were not there, then the mean you would expect them to, the negatives and the positives to balance out each other. But since these positive numbers are there, very large positive, so they drag the mean and away from the 0 to the right, and you have a very positive, significantly positive mean, that is around 12. So you see that the mean of this set of numbers is 12, although you have 9 negative numbers and going down as much as minus 36. But on the right side you not only have numbers to balance these negative values, but you have three very large numbers which would actually make the mean much larger. So such a phenomena is called lack of symmetry, because here the positive values are outweighing the negative values. So this is called positive lack of symmetry or positive skewness. The term is SKUSS, skew NESS. So this data is skewed and positively skewed. So why I have briefly explained. Now you can see this more. And now if I compute the median is a quantile. In R the command is simply same, quantile, QUANTILE. You have to give the data AR, that is the name of the array storing the data, and you have to specify. Remember what was the percentile? 50th percentile was the median. So this is 9.477. Now you see median is slightly smaller than the mean. Why? Because you remember median is less affected by extreme values. So here, because the data, some of the very large positive numbers are there, especially the 3 in the right extreme, so they are dragging the mean even further beyond the median. So this is a typical thing you will observe. When positive skewness is present, then mean will become more than the median. Okay. Now, if you take the other way around, the mirror image of that is, let us look at minus of AR. Minus of AR is the negative of these numbers, and if you, now what will happen is that naturally in this minus of AR, you will have minus 77, minus 64 and minus 71. They will be now negatively skewed. Okay, because now you will have the other way around. So if I sort minus AR, I hope you will not confuse it what I am saying. Then you will have minus 77, minus 71, minus 64, and which are very far away from the to the left. You have some numbers minus 36, for which you have a positive plus 36. Minus 26, you have plus 25, minus 18, you have plus 14. So they are more or less balance each other, but these are numbers that are to the far left. So such a number would be said to be negatively skewed. So please distinguish the difference. So for this data set AR, you have got positive skewness. Why? Because here you have got some positive numbers balancing the negative numbers, but there are 3 extremely large which outweigh the negative numbers. The opposite happens in minus AR. So there can be positive symmetry as well as negative lack of symmetry. So positive skewness and negative skewness. For positive skewness, I am again repeating, the mean will be bigger than the median. Now a question is, how do I quantify this skewness? So there is a measure of skewness. So this measure of skewness is defined as the ratio of 2 moments. In the numerator, I have what we call the third central moment, and these are deviations from mean. Take the cube of that and average them out, divide by the standard deviation cube. So I'll compute it here for this data AR. So mean is 12.72. I will subtract this mean from each of these numbers and then cube them. So this is also very easy to compute. Mean AR minus mean of AR, whole thing cube, and then bracket. So what I have done here, I have subtracted this mean from the individual numbers. So that is taken care of here. I have cubed it and then I have averaged it. See, unlike Fortran or C, here the coding is very simple. So that is a number, very large number. Now I am going to divide it by standard deviation of AR raised to the power 3. That's it. So that is 0.882. So you see, that is, again you revisit this number, the sorted numbers. You see, if I exclude these last 3 numbers, then as I shown that positives and negatives almost balance each other. So if you exclude these three numbers, this ratio would be close to 0. But since these three large numbers are there, they make it positive, and so if this ratio is positive, we say that the skewness is positive. So when this is positive, we say positive skewness. If this is 0, then it is symmetric. For a symmetric data, mean will be equal to median, and the numbers that are above the median will be equidistant from the numbers that are below the median. And for positive skewness, mean will be greater than median, and for negative skewness, it will be mean less than median. Okay, so you can also visualize this with the help of a box plot, Boxplot box plot. I have explained this in my earlier videos. Box plot, if you see, so you see the point that I was mentioning, these are the three extremes, 64, 61, 77, and this is minus 36. If you ignore these numbers and these numbers, otherwise the data is more or less symmetric. So you see this is the median 9 point something, this is the third quartile, and this is the first quartile. So they seem more or less symmetric, but these are the three large extreme numbers which are causing the lack of symmetry, because there are no negative counterparts of this. So you can visualize this skewness using the Boxplot, and you can quantify them using the coefficient of skewness. And last point, what will happen to this coefficient of skewness or skewness if I make this transform? So I leave it as a food for thought for you. Thank you.